Hello everyone, welcome to our channel Code with Sunny, and today we will be discussing the medium problem find all anagrams in a string. Okay, and its index is 438. So this problem is related to strings, and for the case of prerequisites, that is what is being required to solve this problem, the basic maths you need to know, and how to maintain an array, keep updating the array of frequencies. So you need to know some sort of hash tables, or like how to use the arrays efficiently to track the frequencies. So this problem is totally related to the strings and maths. Okay, so let's understand what is this concept of anagrams, and we need to find all the anagrams in a string. So given two strings s and p, return an array of all start indices of p's anagrams in s. Like we would be given two strings, string s and string p. We need to return all the substrings of this string s which are anagram to the string p. You may return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or a phrase, typically using all original letters exactly once. Okay, so let me tell you the concept of anagrams in simpler words. So let me first move out to the next page. So given two strings s1 and s2, so s1 and s2 are said to be anagram to each other. If we rearrange any of the strings, like this one, let's call this as s1, rearrange s1, and by rearranging s1 in any way, we would get s1 exactly matching with s2. That is their lengths would that is the s1 length and s2 length must match, and s1 of I must match with s2 of I for every I belongs to their range, that is from 0 to n minus 1. Okay, so in other words, you can also understand that anagram is nothing but if you track the frequencies of characters occurring in s1 and s2, frequencies of characters, like let's call that frequency would be a dp1 vector, would be of size 26 because it consists of lowercase characters, and we need to transform their positions to starting from 0, and dp2, which would actually denote the frequencies of characters present in s1 and s2, which is also of size 26. So s1 and s2 will be of anagram to each other if for all I belongs to, let me write down, for all I belongs to 0 to 26, dp1 of I must match with dp2 of I. Then the strings s1 and s2 is said to be anagram to each other. Okay, so like we need to return all the starting indices present in this one, that is going to be anagram to the string p. So let's look over the constraints first. You can see their lengths can go up to 3 into 10 raised to the power 4. So O of n square solution will not be valid, so we would be looking for some better solution. Okay, so let's first understand how this answer is coming about, and then we will together build up the idea to find out this to solve this problem efficiently. Okay, so let me just erase this. So we have the string as C, B, A, E, and B, A, C, D. So this is our string S, and we have a string P called ABC. So we need to return the anagrams, like we need to search for all those substrings which are anagram to the string P. Note that the length of this string P is 3. So the brute force solution is to consider every substring of size 3. That is, first we consider CBA. So we have CBA. Let's call this as S1, and we have S2, which is nothing but a string P, ABC. Can this be an anagram with respect to each other? Yes, because every unique character has their frequencies being matched. You can see A's frequency is 1, B's frequency is 1, C's frequency is 1, and here also A's frequency is 1, B's frequency 1, and C's frequency is 1. Okay, so you can see this is anagram of each other. So we need to return the starting index. So our answer would contain 0, and there might be more indices that will be appended to the answer. So we need to check out for every substrings of length equal to 3. So let's consider BAE. You can see the character E is present, but E is not present over here. So this cannot be a substring. Similarly, you need to check AEB, and then similarly EBA, and so on. You need to check out for every 3 length substrings. So the time complexity it would do for such operation can go in worst case as O of n square. Okay, so it might go like O of n square into 26, because you need to match their frequencies also. So this is the worst case complexity that you can have, like if you do a complete brute force solution, like implement a complete brute force solution. So you can see this will obviously not going to pass. Okay, so how do we find out the best solution for this problem? Okay, so let's understand this with some optimization techniques, like how do we optimize our same concepts. Okay, so you can see I've already drawn some table. So let us fill out, and we'll be putting some names first. So here I would be tracking the demand frequency, which is nothing but the frequencies of characters in a string P, and this is our substring frequency. Let me write down substring frequency. So like I have taken the same example, this is actually string S, and let me first change out the color. So this is actually our string S, and we have a string P also. Let me write down over here, which is actually nothing but ABC. Okay, so we have the characters over here as we need to track for the character A, character B, character C, character D, followed by character E. That's all we need. Okay, so let's try to fill out this table. You can see for the demand frequency, it is nothing but the string P. So we would filling the frequency of A as 1, B as 1, C as 1, and D and E will hold the frequency as 0. Now talking about this substring frequency, we need to search for every 3 length substring, because the length of this string P is actually 3. So how we are going to do that? So the very first case would be like first substring of length 3. So let's fill out their frequency. So you can see frequency of C is 1, B is 1, and A is also going to be 1. Now the rest of the entries will be 0. Now how you are going to check it out whether the substring CBA is going to be anagram with respect to the string P? You can see you need to match the frequencies of every character that is present over this hash table. Okay, you can see 1 and 1 are matching, this one is also matching, this one, and this one. If all the characters are matching, that is the frequencies, so you can say that yes, the first substring CBA is an anagram with a string P, which is nothing but ABC. So you need to append the answers as like the very first index also. So this one. So you can see like 0 is present over here. It will denote the starting index of the substring, which is anagram with respect to string P. Okay, so what about more answers? Let's try to do that. So like we are trying to modify this substring frequency table. Okay, how we are going to do that efficiently? Let's understand. Like we have already done for CBA. So the only thing that differs is as we move out to the next character, the frequency of this character is decremented by 1. If you look out over the substring pattern efficiently, like you are at this one, you will try to append this, like you need to increment the right bound of this substring to the next position. So it would be I think why it is being erased. Yeah, so it would be incremented to this one, and this left bound will be decremented to this one. Okay, so this will be your actual substring frequencies. Like you need to consider this substring. So we are going to do nothing but a simple logic would be like incrementing the frequency of E, so it would become 1, and decrementing the frequency of C, so from 1 it would go to 0. Okay, now the thing like you need to check out again is like try to check it out whether the unique characters have the same frequency, like 1, this one, this one, this one, and this one. Can like these frequencies are matching or not? You can see that this is matching, yes it is okay, and B is also matching, yes it is okay. C is not matching, so this is not matching. So with if you found a character whose frequency is not matching, so BAE cannot be the anagram with respect to the string P. Okay, so in that case you are not going to consider this starting index 1. Okay, so like similarly, if you move out to the next one, you would increment the frequency of b and you will decrement the character which is present at I minus m index, where m is nothing but the length of the string p, len of p. Okay, you can you determine the time complexity of this entire thing? Okay, so you need to iterate for exactly n positions, not saying it as exactly, like in the worst case n positions, and for every positions you need to check out for this frequency table which is of size 26 because of lowercase characters only. So the time complexity would be O of n into 26, and a space complexity that you need to maintain is only this frequency table which is 26. Okay, so this is the entire thing. Like if you look out for the answer is coming out to be 6. Let's try to check it out whether it is correct or not. 0 1 2 3 4 5 6. Okay, so if you consider the character BAC, like suppose you are at this one first, ABA, but you can see like if you are at ABA, so A's frequency is 2, B's frequency is 1, and like C's frequency is 0, D's frequency is 0, and E's frequency is 0. But as soon as you go out to this character C, you can see C's frequency becomes 1, and you need to decrement the character who present at I minus mth index, whose character is A, so you need to decrement A to 1. Now you can see everything is going to match, like the frequencies of all the unique characters is going to match with the string P, like ABC. You can see over here. That's why the answer that we are going to get is at the 6th index, if we consider a zero based indexing. Okay, so the time complexity will be O of n into 26 and space would be O of 26. But we can still optimize this time complexity to O of n. How we are going to do that? So let's try to understand this one also. Like yeah, so the only thing that matters over here is like number of characters. Let me write down number of characters which doesn't reached desired frequency. Let me write down demand frequency. Let's say demand frequency, like how many characters which doesn't reach the demand frequency. Suppose you are at this position BAB, so you would write down as B as 2, A as 1, and rest of all as 0. So what are the number of characters which are not equal to the demand frequency? So 1 plus 1. So there are 2 characters which are not equal to the demand frequency. So the only data that we need is the number of characters which are not equal to the demand frequency. If this value is capital, let's say capital D. So if capital D equals 0, it means that all the characters have reached to their demand frequency. In that case, the current substring that we are going to talk about is going to be anagram with respect to the string P, because all the characters have reached to their demand frequency. So how do we update this capital D efficiently? Let's try to understand that. So what I am going to do is, like suppose we are incrementing the character A, like frequency of character A. So for an example, let's say the current frequency of character A is going to be like the previous frequency I'm talking about is 5. Now the frequency of character A is going to be increased by 1. So let me write down previous, and my new frequency, let me write down over here, it becomes 6. Okay, so let's say the demand frequency of this character A, let me write down demand frequency of character A is 6. Okay, so what I'm going to do is like let me first change out the color because it might confuse you. So wait a minute, let me move out to the next page, it would be better. Okay, so A, let me write down A's frequency is 5 and A's frequency becomes 6 because we have incremented this one, and A's demand frequency is 6. So let me write down demand new frequency as we incremented, and this is the previous frequency. Okay, now consider that previous frequency of A is 5, and when we incremented this one, it becomes 6, and now it becomes equal to the demand frequency, that is 6, and 6 is now matching. Now when we are talking about like when we are at the previous case where the frequency of A is 5 and demand frequency of like A is 6, Now deviation must be have a deviation, which is number of characters which are not equal to their desired frequency. Let's say it is having some value capital, let's say small d. Okay, so when this is happening, like previous frequency of A is 5 and the demand frequency of A is 6, now deviation is d. Now as we incremented this 5 to 6, this is matching with their demand frequency. In that case, my new deviation d dash would become what? D minus 1, obviously, because now it is matching. Okay, so we need to keep track of this case, like whenever we are incrementing some character frequency and it now matches with their demand frequency, it means that we need to decrease the deviation by 1. Okay, now let's consider another case, and another case would be okay, so I am going to write down as like previous frequency is 6 again, and my new frequency would become 7 and my demand frequency is 6. Okay, now consider this case, like previous frequency of A is 6 and my new like demand frequency is also 6. Now both are matching. Let's call that as deviation at this point, like at the previous stage, as d. Okay, now when we increment this frequency, like the previous frequency, by 1, now new frequency would become 7, and 7 and 6 are not matching. So in that case, you need to increment the deviation, new deviation, as d plus 1. Okay, so this is the case that you need to keep track of. And similarly, the case lies for if you subtract the frequency of I minus mth position, where m is the length of the string p. So in that case, you need to work accordingly. Okay, so without wasting our time much, let's understand this entire thing with the help of coding part, which will help you to understand this one better. You can see I have a 3ms code, which is quite faster because I have a O of n, like max of n into 26 time complexity solution. Okay, so I hope you can see my screen. So n is string's length and m is p's length. So if m is greater than n, this is not possible. We cannot have any substring of the desired length. Now p is an anagram of some substring of s, then their frequency must be same. So let's keep track of demand frequency and substring frequency. So demand frequency of like we need to increment the characters of every frequency of string, like characters present in string p. And similarly, first I will keep bring out the first substring of length m from the string p. You can see iterating exactly m times and picking it out the characters of string s. Okay, so now we need to find out the deviation, number of characters whose frequency are not equal to the demand frequency. So I will iterate for 26 times and will be incremented when demand frequency for any character is not matching with the substring frequency. Okay, now so if deviation is 0, so our first answer will be pushed back, which is the 0th index. Now we will consider every coming substrings of length m. So I start from m and go up to n and pick out work for every substring. So the only thing is like you need to add the character at present at ith index and subtract the character frequency whose present at I minus mth index. So what I am going to do is like increment the substring frequency, like the current window frequency of the character s of I by 1. Now if the frequency matches now, it means that previously it is not matching and previously it is contributing to the deviation. Now if it is matching, so it means the deviation is going to be decreased by 1. So if substring frequency is going to match with demand frequency, now deviation will decrease. Okay, now what about if the substring frequency is going to be is the difference between the substring frequency and the demand frequency for the current character is exactly 1. It means that previously it is matching and now it is not matching, so deviation would be increased by 1. And similarly the case lies for the character present at I minus mth position. We need to decrement it, and if they are matching right now, we need to decrement the deviation because previously it is not matching and it is contributing to the deviation. Now it is matching, so it won't be contributing to the deviation. So now again you need to check out if the difference of demand frequency and substring frequency becomes exactly 1, you need to increase the deviation because previously it is matching and now it is not matching. Now the same thing lies for, you need to check out for this current substring. If deviation is 0, you need to push back the start index of the current substring, which is I minus m plus 1, and finally return the answer. This will give you all test cases passed. So the time complexity will be 3ms, and so runtime would be 3ms, and time complexity would be max of n into 26, and the space complexity would be 26, because we need to keep track of 26 size array, like we are making an 26 size vector, and time complexity would be max of n into 26, because there might be the case like the string s have lesser length than this 26. In that case, still we are maintaining the 26 size vector. That's why we have the time complexity as max of n into 26, like n comma 26. Okay, so if you guys have still any doubts, do reach out to us in the comment section of the video, and thank you for watching this video.